All right. So everything we've done up to now, we've done adding, subtracting, multiplying, and dividing the expressions so that we would know how to simplify them. And today we are starting with solving rational equations. When we're solving that is not how you spell equations. Equations. When we're solving, we are looking for the value of the variable that makes it true. So at the end, what we're looking for is that x equals something, right? And that something that it equals can't have an x in it, right? So if I have a problem where I need to solve, say, -5 plus x over x minus 9 equals 9 over x minus 9, the whole thing that I have to do is figure out what x is equal to, right? And the way we do something like this when we have a fraction, which is everything we're dealing with, right? Everything we've been dealing with so far has been rational equations, which means we're dealing with fractions. But in this case, we can get rid of that fraction, right? The first thing that I want to do is I want to get both of those fractions on the same side of the equal sign. So I'm just going to go ahead and subtract x over x minus 9 from both sides, right? What it does here is it just cancels it out completely, and I'm left with -5 equals 9 minus x over x minus 9. And I can put these two numerators together because they have the same denominator, right? If they had different denominators, I couldn't do this. But because they both have the same denominator, I can combine this 9 minus x right here. Now, I still have a denominator, right? I have a fraction still. Does anyone remember how to clear the denominator of a fraction? Getting all static here in the nobody remembers how to clear the denominator of a fraction? You're allowed to say no. All right. Here's all we have to do. If you want to clear out the denominator of a fraction to get rid of your fractions, all you have to do is multiply both sides by that denominator. So if I multiply both sides times x minus 9, I can clear it. The one thing you have to remember to do, though, is I have -5 right here. This is not -5. We're multiplying it. So make sure and put that -5 in parentheses so we know to distribute it. But what this allows us to do is it cancels that denominator, right? And so when we do this now, we'd go -5 times x. Well, that's -5x. -5 times -9. Well, that's plus 45 equals 9 minus x. And now this is a more familiar solvable problem. Now we just get all our x's to one side and everything else to the other, and we know how to solve this problem, right? I'm going to start by moving this x over. I'm just going to add x to both sides. And I get -4x plus 45 equals 9. And now we just have to start undoing everything that's happening to the x. So here we've got 45 being added to it. So we're going to subtract 45 from both sides. And we wind up with -4x equals negative 36. 9 minus 45 is 36. Now we're not done yet because we don't have x by itself. We still have negative 4 being multiplied to it. So I'm going to go ahead and do the opposite of multiplying and divide by negative 4 on both sides. And I wind up with x equals positive 9. This is a solution. A solution means that if I were to plug 9 in for x in every aspect of this, we would wind up with a true statement, right? That's all it means. Do I need to test it? No, right? We're just trying to solve this rational equation. We're just trying to get to the bottom of it. Now, this is a level 1 problem that I took out of Delta Math. We also have these level 2 problems that we'll have to do. I'm going to skip this other level 1 problem I have because it's basically the same problem. And we're going to move into the level 2s because I think that's what you're going to need to see more of. So let's get another one of those going. And the level 2s, if I have 2x minus 3 over x plus 2, sorry, x plus 2 equals x. When I have a problem like this and I have x's that aren't part of the fraction as well as x's that are part of the fraction, I separate the fractions and the not fractions. What does that mean? That means I am going to move this x over by subtracting x from both sides so that I have 2x minus x is just x minus 3 over x plus 2 equals 0. And then I'm going to move this to the other side. And all I'm going to do is add 3 over x plus 2 to both sides, right? Plus 3 over x plus 2. And I'm showing you absolutely every step. Like I could look at that and know that I could just put right 3 over x plus 2. And here I would be left with x equals 3 over x plus 2. And now I'd do the same thing. I would get rid of my denominator by multiplying both sides by the denominator, right? So this would be x plus 2, and this would be times x plus 2. And these cancel, right? And here I'd have x times x, well, that's x squared. And here I'd have 2 times x, well, that's plus 2x equals 3. And you're like, man, what do I do with all these x squares? I can't combine an x squared and an x. But what I see here is a quadratic, right? If I move this 3 over to the other side, if I subtract 3 from both sides and I rewrote this problem, I'd have x squared plus 2x minus 3 equals 0. And that allows us to factor this or use the quadratic form. Now, this is a really easily factorable problem because we would be taking the factors of 3 that add up to 2, and 3 only has 2 factors, 1 and 3. And with 3 being negative, we know we'd have to have x minus something times x plus something equals 0, right? And because our 2x is positive, we know that our smaller number would be the negative 1, right? If this was a negative 2x right here, we would know that the negative 3 would have to be bigger because 3 minus 1 is positive 2. But if I needed to get a negative 2, it would have to be minus 3 plus 1. And that's how we kind of determine that. And so this would be 1, and this would be 3, and they would be equal to 0. And when it comes time for our actual solutions, we would set each of these factors equal to 0. Because think about this. When I multiply something times 0, it equals 0, right? And these two things are being multiplied together. This and this are being multiplied together. So if either one of them is 0, the whole thing becomes equal to 0, and it's true. Well, what would make what's in here equal to 0? What value for x could make this equal 0? What minus 1 equals 0? Exactly. 1 minus 1 equals 0. So here I have x plus 3. What would make that equal to 0? If I had to add two things together, what would make x plus 3 equal 0? What could I put in for x that would make that equal to 0? Well, that one's a little harder, but kind of not either. If you remember, we have negative numbers. Grace, what would make x plus 3 equal to 0? What value for x? Yeah. So there is a way to just solve them to figure it out. But most of the time, you can look at these problems and figure out what your solutions are. Because you're going, well, what would make this 0 and what would make that 0? And those are your solutions. Or you could just set each one equal to 0. You could go x minus 1 equals 0. And then you could add 1 to both sides and you get x equals 1. And then you could do the same thing for x plus 3 equals 0 and then subtract 3. And you would get x equals negative 3. Or you could just look at them and know, right? You're putting this in delta math, right? It makes it a little bit easier to go, okay, I know the answers to this are just 1 and negative 3, right? They're just going to be the opposite sign of whatever's in that box with it or in that parentheses with it. So I'm going to do one more that's like this just so that you could see it. And then I think, unless you guys feel like you need more examples than this, I'll let you guys go. I didn't do this one in my last class, but I'm going to do it with you guys. So we'll see how it goes. I haven't solved this one out yet. X minus 3x over x plus 1 equals 3 over x plus 1. So we're going to do the same thing we did with the last one, right? We're going to move this piece here over there, right? We're going to just add it to both sides so that all we're left with over here for right now is the x, and we have both our fractional parts on the other side. They have the same denominator, so we're in luck there. We don't have to find new denominators. We're not even going to deal with any problems that have different denominators until later this week. So we're going to go through and we're just going to add 3x over x plus 1. And we're going to go plus 3x over x plus 1. And here we're going to be left with x equals 3 plus 3x over x plus 1. And now we can really start solving this, right? We can go, okay, well, I need to clear this denominator. And the way I'm going to clear it is I'm going to multiply both sides by x plus 1, right? Because when I do it here, it cancels. When I do it here, we've got to distribute that, right? And so we're going to go x times x is x squared. X times 1 is just plus x. And this is going to equal 3x plus 3. It doesn't matter which order I write those in. They're both positive. They're just being added together. I can add them in any order. But if you wanted to write it the other way because it makes you feel more comfortable to write it as you see it, that's fine too. So now we're going to move everything over to the other side. We can do it one step at a time, right? I could add 3x here plus 3x here, and I'd have x squared plus x plus 3x is 4x equals 3. And again, now we're at this point where we're looking at a quadratic, right? We have an x squared and we have a 4x. So we're just going to move this 3 over, right? We're going to subtract 3 from both sides so that we have that full quadratic equation. Plus 4x minus 3 equals 0. And so now we can look for our factors of 3 that equal 4x. But really, we don't have any, right? We don't have anything that's going to add together that would give me a negative 3, right? Which means that we have to use the quadratic equation. We have to go back in our toolbox and remember the quadratic equation. And if you remember, that is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. What are our a, b, and c? Well, whatever is in front of x squared is a. Whatever is in front of x is b. And whatever is not attached to any x is our c. And we're just going to plug those numbers in, right? In this case, our a equals 1, our b equals 4, and our c equals negative 3. And we're just going to plug those into this formula, right? We got minus b. Well, minus b would be minus 4 plus or minus the square root of b squared. Well, that is just 4 squared minus 4 times a, which is 1, and c, which is negative 3, all over 2 times a. 2 times a is 2 times 1. And then we just solve that, and it will give us our 2 solutions, right? And this, sometimes it does not let me scroll up until I change that. So remember to take your quadratics a piece at a time. This is minus 4 plus or minus, right? 4 squared is 16. Minus 4 times 1 is negative 4. Negative 4 times negative 3 is positive 12 over 2 times 1, which is just 2. And so now we have minus 4, plus, or I gotta erase that. It looks like I'm dividing. Now we have minus 4 plus or minus the square root. Well, what's 16 plus 12? 28 over 2. Right? This is going to be an ugly answer. That's okay. We can have an ugly answer. Here's the thing. Plug this into a calculator because you're doing it on Delta Math. But if you weren't doing it on Delta Math, when it comes time for the test, I'm not going to give you a problem that you have to reduce like this. It'll be more like one of the ones that we factor. So you could always plug this into a calculator to get the answer, but make sure it's one that puts it in a radical, like an online calculator. This is minus 4 plus or minus, I could break down 28 is 7 times 4. And so I know that this is a perfect square, so that's 2 times the square root of 7 over 2. Not our answer yet because everything's divisible by 2. So we get negative 2 plus or minus radical 7 when we reduce it. And I know you're saying to yourselves, if you are, I don't know, that's only one answer, but it's not. It's negative 2 plus radical 7 and it's -2 minus radical 7. And that is as difficult as anything that you'll come up with on your homework. If you don't remember how to do the quadratic formula, open up an online calculator. I hope that you practice it, but open up an online calculator. I'm not testing you on the quadratic formula here today, right? It's about the procedure of solving the rational expressions, right? So, no, I'm not doing a final in the class. I don't do finals. Yeah. This is the last example of the day today, unless you want another one. I do have another one. But I feel like I've kind of showed you every type of equation that you might come up with in the homework. And like I said, I pulled them right out of the problem sets that I chose the homework as. I mean, you might even come across one of these because, it randomizes it. But everything is in Delta Math. You have 5 of the first kind. You have 5 level 1s. You have 5 level 2s. There's no penalties. So anyone can get 100 on them because you could just keep going until you get them all right. I'm going to stop my recording now.